Welcome to Lesson 3.1 of the Claude Forge course. I'm glad you're here for this one, because this lesson is the hinge point of the entire module. Module 3 is called Agentic and Headless Workflows. Everything in it, the batch processors, the self-healing pipelines, the GitHub Actions integrations, runs on top of one flag. And that flag is what's on the screen right now, --print. We're going to spend the next 20 minutes understanding exactly what that flag does, why you need it, and how to use it in a way that holds up in production. By the end, you'll have the complete mental model and a working batch processor you can adapt to your own codebase tonight. Let's get into it. Before we look at the solution, let's understand the problem. Here's a concrete scenario. You have a monorepo with 340 Python files. Your team agreed on Google-style docstrings 6 months ago. None of the existing files have them. The API documentation generator runs on Friday. It's Tuesday. The first instinct of a developer who uses Claude.ai every day is to open the chat, paste a file, get back the documented version, copy it over, and repeat. The second instinct, once you realize that's obviously 340 manual cycles, is to write a script. That's the for loop you see on screen. Redirect stand it in and stand it out. Looks completely reasonable. It breaks immediately, and not in an obvious way. The issue is architectural. Claude Code's interactive REPL wasn't designed for pipes. It was designed for a human terminal. So alongside your response, it emits terminal control sequences, escape codes that clear lines, carriage returns for the spinner animation, progress indicators. All of that goes into your redirected output file. What you get on disk isn't a Python file with docstrings. It's ANSI escape noise with Python fragments embedded in it. The diff command can't parse it. JQ throws a parse error. The file is corrupted. The real cost isn't just time, it's consistency. Every developer doing this manually produces subtly different docstring formats. There's no audit trail. And if your script gets interrupted at file 200, you have no idea which files were done and which weren't. The root cause is architectural. Interactive mode was built for a human TTY. There is no mechanism to separate Claude's response content from its UI Chrome in that mode. You cannot grep or sed your way out of this. The model is wrong for scripted use. That's the problem. Let's look at the one flag solution. This slide is the core mental model. Everything else we cover today is a consequence of understanding this comparison. On the left, interactive mode. 6 properties, all of them problems for automation. ANSI codes mixed into output. No JSON envelope. Exit code is always 0, so you can't distinguish success from failure. And the turn depth is non-deterministic. Claude decides how many agentic steps to take. The orange arrow in the center represents the --print flag, or its alias, -p, one flag. On the right, what you get. Standard in goes in, clean response comes out on standard out, wrapped in a JSON envelope that your scripts can parse. Exit code reflects the actual result. 0 for success, 1 for a retryable error, 2 for a script bug. And you can cap the turn depth with --max turns. This is what UNIX filter means. 1 input channel, 1 output channel, meaningful exit codes. Composable with every other tool in your pipeline. You can pipe the output to JQ, you can tee it to a file, you can feed it into Python's JSON.loads. You can use it in a GitHub Action step. None of this works with interactive mode. All of it works with --print. The key insight at the bottom of this slide, Claude --print equals Claude-p. They're identical. Use whichever is less typing. The important thing is that you understand why this flag exists. It's the architecture decision that makes Claude Code composable. Let's look at what the full pipeline looks like. Walk through this left to right. This is the complete picture of what we're building in this lesson. The src directory on the left is your file corpus, 340 Python files. Your batch script iterates them, but not blindly. Singleshot.sh in the center left is the orchestrator. Before it invokes Claude for any file, it checks one thing first. Is this file's path already in .claude/processed.log? If yes, skip. If no, proceed. That check is what makes this restart safe. If your script is interrupted at file 200, you restart and it picks up exactly where it left off, not from the beginning. The dark box is the Claude --print invocation. 4 flags every single time. Output format JSON, so the standout is parsable. AllowedTools read, write. This is your CI safety boundary. Claude can read files and write files, but it cannot execute arbitrary bash commands on your runner. Max turns 1, caps the agentic depth, and the prompt arrives via heredoc. The dashed box on the right is the Anthropic API. It's dashed because it's external. It crosses the boundary of your system. You control what goes in and what comes back, but you don't control the network or the service uptime. Handle that with retry logic. The teal JSON envelope box is what comes back on standout. We'll go through each field on the next slide. That JSON gets parsed, the metrics get appended to a JSON-L file, and the file path gets appended to processed.log. The exit code contract at the bottom is the operational brain of the pipeline. Exit 0, success. Append path to state log, continue. Exit 1, retryable error, usually a rate limit. Implement exponential backoff, up to 3 attempts. Exit 2, script bug, bad flag combination. Stop the pipeline immediately and fix the code. That's the architecture. Let's look at the implementation.
29 lines. This is the complete pattern. Let me walk through the critical sections. Line 2, set-EUO pipe fail. This is non-negotiable. Without it, a failed Claude call, a rate limit, a network fault, doesn't propagate the error. The loop continues to the next file. It looks like success. You get partial output with no indication of which files failed. With set-EUO pipe fail, any unhandled error stops the script. You know exactly where it broke. Lines 11 through 14, the state file check. grep-qxf is an exact full line match. If the relative file path is already in processed.log, we print skip and return. This O of 1 check is what makes the entire pipeline restart safe. Lines 16 through 22, the Claude --print invocation. 4 flags. Notice lines 17, 18, and 19. Those are your 4 mandatory flags. And the prompt arrives via heredoc on line 21. Always single quote the prompt delimiter. That prevents shell variable expansion inside your prompt text, which can cause subtle bugs when your prompt contains $signs or backticks. Lines 24 through 25, the case statement on exit code. Exit 0 is the happy path. Log metrics, append a state file, continue. Exit 1 is recoverable. Call the backoff retry function, which implements exponential backoff with up to 3 attempts. Exit 2 is a programming error in your script. Stop the entire pipeline immediately. You do not retry exit 2. The first annotation note reinforces set-EUO pipe fail. This is where most naive batch scripts fail. They look correct. They run to completion. They produce partial results with 0 diagnostic output. Now, let's understand what comes back from that Claude invocation. 2 code blocks on this slide. The left is what --output format JSON gives you. The right is what --output format stream-json gives you. Different shapes, different use cases. Left block, the JSON format. 5 fields. Result, Claude's actual response text. For a docstring task, this should be a short confirmation. Parse it to verify Claude didn't refuse or output something unexpected. Cost_USD, your billing sentinel. If you're using Claude.ai Pro subscription, which is the correct auth for modules 1 through 7, this field is always null. If you see a decimal number here, your Anthropic_API_key environment variable is active and overriding Pro subscription billing. Run Claude auth status immediately. Duration_ms, your performance telemetry. Track P50 and P95 across your file corpus. Files consistently above 5 seconds are hitting context window pressure. The file is too large for one turn. Chunk those by class or function group. Num_turns, your prompt efficiency signal. A docstring task should return num_turns of 1. If you see 3 or higher, Claude is doing more than you asked. Tighten your prompt or add a claude.md constraint. Write block, stream-json. This emits 1 ND JSON line per event as the response streams. You can see the message start, content block delta, and message stop events. Use stream-json when you need to display progress before the full response completes, or when processing very large files where waiting for the full JSON payload is impractical. The decision rule in the center, use JSON for batch processing. Use stream-json for live dashboards or large files. For this lesson, JSON. The bottom two cards reinforce the two most important diagnostic signals, num_turns and cost_USD. Memorize what they mean. Check them after every first run in a new environment.
5 failure modes on this slide. Every experienced team hits at least 3 of these. Let me go through each one. Top left, critical, Anthropic API key override. This is the most expensive surprise. If this environment variable is set in your shell, left over from a Module 8 experiment or copied from a .env file, every single Claude invocation silently routes from your flat Pro subscription to per token API billing. There is no banner, there is no warning. The output is identical. You discover it when the invoice arrives. Run Claude auth status before every batch session. It takes 2 seconds. Top center, critical, ANSI stat out pollution. This is the architectural mismatch we covered on the problem slide. The fix is complete and simple. -- output format JSON. That's it. Top right, warning, exit code swallowing. Set -EUO pipe fail is necessary but not sufficient. You still need explicit case matching on exit code because the pipe fail option only catches unhandled exits. A Claude call that exits 1 inside a command substitution needs your explicit handling. Bottom left, warning, reprocessing on restart, the economic argument. At 2,000 tokens per file pair, reprocessing 200 files costs 400,000 input tokens. The grep tech against processed.log costs microseconds. This is not a premature optimization. It's basic operational hygiene. Bottom center, note, uncapped agentic turns. Without --max turns 1, Claude may take 3 to 5 steps per file. This produces non-deterministic runtime in CI and unpredictable token cost at scale. For single file tasks, always set max turns 1. Bottom right, the state log atomicity note. On macOS EPFS and Linux ext4, a single append is atomic for short strings. On Windows WSL2 with a DriveFS mounted file system, you need flock if you're running concurrent processors. For sequential processing, which is this lesson, you don't need it. 2 mechanisms that are often overlooked but matter for production safety: Claude.md and the allowedTools flag. Left panel, Claude.md. This file is read by Claude Code at the start of every --print session, before any prompt is processed. The section called Headless Mode Defaults is treated as a system-level constraint, weighted above your inline prompt content. This means you can set project-wide defaults once in Claude.md and not repeat them in every prompt string. Put your strictest do not touch constraints here, because --print never prompts for confirmation. Claude will act on the first interpretation of your instructions. If your constraint isn't in Claude.md or the prompt, it doesn't exist. The warning at the bottom of the left panel, --print never prompts for confirmation, regardless of Claude.md. There is no "are you sure" step in headless mode. That's a feature, but it also means your constraints need to be explicit. Right panel, the allowedTools table. Case sensitive, exact match. The valid values are read, write, bash, web fetch, to-do read, and to-do write. A typo like read, lowercase r, silently restricts all tools. Claude receives an empty tools list, can't read or write any files, and returns exit 0 with a message saying it can't help. Completely silent failure. Always test your tool allow list with a single file dry run before running a batch. The CI-safe invocation pattern in the dark box, the correct allow list for CI is always read-write only. Never include bash. If bash is allowed, Claude can execute arbitrary shell commands on your runner. I've seen this produce correct output while also running unintended shell commands. Scope your tools at the call site for CI environments. This is the complete picture of what happens to every file in your batch. Understanding this state machine lets you diagnose exactly where a run stopped and why. Top row, the happy path. Unprocessed on the left. At the start of each iteration, the script checks processed.log. Not in the log, transition to in context. Claude's single-shot session is running. From in context, the API call goes out. That's the -API pending box. Dashed because it crosses the external boundary into Anthropic's infrastructure. You don't control this step. You only control your timeout and retry handling. Exit 0 brings you to diff generated. The JSON response is in memory.
From there, the path gets appended to processed.log, accepted, and git commit brings it to committed, the terminal success state with the double border. Double border means terminal. That work is durable. Branch paths. If the file's path is already in process.log at the start, skipped. Also a terminal state, also double border. Exit 1 from in context goes to retry wait, the amber dashed loop. After the backoff delay, it returns to in context. After 3 failed attempts, it transitions to failed, red terminal state. The key production insight. If your script is killed mid-run, the only files that get reprocessed on restart are those that were in context at the moment of termination. Every file that had already reached accepted is protected by the state log. That's restart safety in practice. The legend at the bottom. Double border is initial or terminal. Orange arrows are success transitions. Amber dashed is the retry loop. Red is failure. Gray dashed is external or skip.
Let's zoom out and see where today's primitive leads. The timeline shows 5 lessons. Today is 3.1, highlighted in orange. The remaining 4 are what you can build once you have the -- print primitive working correctly. Lesson 3.2, piping std in. You pipe git diff head directly into Claude -- print. The same pattern, subprocess, std out capture, JSON parse, applies whether std in is a diff, a test log, or a build failure. The output format JSON flag is the same. The state file is the same. Only the prompt changes. Lesson 3.3, batch type hint adder. The state file pattern from this lesson applied to a different transformation. Different src dir, different prompt, same architecture. Lesson 3.4, the self-healing write-run fix loop. Claude writes code, you run it, the test failure's stdr becomes the next -- print prompt. The exit code from the test runner becomes Claude's feedback signal. That's where agentic starts to mean something concrete. Lesson 3.5, GitHub Actions. A workflow step invokes Claude -- print -- output format JSON, captures stdio, parses it with JQ, and posts a structured review comment via the GitHub API. Claude becomes a first-class CI participant. Every one of these is -- print plus a coordination wrapper. Most developers skip this lesson and go straight to the frameworks. Then they can't debug why their pipelines break, why their costs are wrong, or why their CI steps produce non-deterministic output. Master the primitive. The patterns compose. 5 principles. These are the decision heuristics. What I want you to still know in 6 months. 01. -- print is the UNIX filter primitive. Interactive mode was built for humans. -- print was built for programs. Once you have this distinction, every automation decision downstream becomes clear. 02. Always use 4 flags together. Output format, JSON, allowedTools, read, write, max turns 1, heredoc prompt. They're not independent options. They work together to produce a deterministic, safe, parsable result. Test with all 4 or don't test at all. 03. The state log is not optional. At 2,000 tokens per file pair, 200 reprocessed files is 400,000 wasted tokens. The grup check costs microseconds. 04. Exit code contract. 0. Log and continue. 1. Back off and retry. 2. Stop immediately and fix the script. Never swallow exit codes. 05. Cost USD null confirms pro subscription. A decimal means Anthropic API key is active. Check this field after every first run in a new environment. The homework at the bottom of this slide is concrete and achievable in 45 minutes. Pick a directory in your codebase with 5 to 20 Python or TypeScript files lacking doc strings. Copy single.shot.sh, update src dir, adjust the prompt for your language, and run it on a feature branch. Commit the diff plus the metrics.json file as a pull request. The metrics file is the important part. It's the first concrete evidence of per-file token cost in your specific codebase. Keep it. You'll use it to extrapolate what a full repo pass would cost. You now have the automation primitive. Everything else in Module 3 is a coordination wrapper around this single foundation. The command to remember on the bottom left of this slide. Read it once. Claude -- print
-- output format JSON, -- allowedTools, read, write, -- max turns, 1. That's the command. 4 flags, every batch job, every CI step, every automation in this module. Lesson 3.2 is next, piping shell data into Claude. Git diffs, test output, build logs, all of it can become structured prompt input for your single-shot calls. The architecture is identical to what we built today. Resources on the right if you want to go deeper before the next lesson. The Claude Code documentation at docs.anthropic.com is the authoritative source. Running Claude --help on your terminal shows you every available flag with current defaults. Good work today. See you in 3.2.